All right. Hello, everyone. So today we are going to talk about exponential growth and decay, but this time it's going to be with word problems. So here we have our two different functions for growth and decay. So I just wanted to remind us that our original function was y equals a times b to the x power. So these are going to be extremely similar to that. The only thing that's missing is going to be our b. So our b is actually right here. It's just broken down a little bit farther so you can see exactly where we get that number from. So we still have an a, we still have, this is going to be our b, and we still have an exponent, but instead of x this time, we're just using t instead. But this is essentially the same idea as this guy here. Okay. Other thing I wanted to point out, the only difference between growth and decay is going to be these signs here. For growth, we're adding on, and for decay, we're subtracting. Otherwise, these are going to be about the same idea. So let's take a look at our growth first here. All right. Exponential growth, we have an A, an R, and a T. A, oops, that's a little big. Let me make that smaller. A is going to be our initial value. Now, we learned that word in the last set of notes. That's where we're starting off, at. So I'm going to say initial value or starting point. So in all of these questions, they're going to give us some number to start off with, and that will be our A. Okay, next up we have our R. R will be our rate. Before we use the word ratio, which also works, or percentage. All of these questions will show us a percentage. This is a little percentage sign. And we're going to use that as our rate, or how much it's increasing every interval. And then we have our T. That is going to be time. Time T. So that's about it for this. Basically, what we're going to do with these questions is find each of these pieces and then plug them into our equation and then solve it. But that's about all we're going to do with these. It's just going to be the context that will change for each question. So let's take a look at this example. The exponential function below models the amount of money in Jose's savings account, where x represents the number of years since he invested the money. So this is what we got. 3,000 times 1.06 to the x power. The first question is asking us, what does the 3,000 represent? Okay, so let's take a look at that formula one more time. So I'm seeing that that is the first number in our equation, A. A is our initial value. So, initial value, or in the context of the question, it says that this is Jose's savings account. So this is how much Jose started with. When he opened his account, he was like, I'm going to put $3,000 in there. That's where he started from. Okay. Question B, what is the growth rate? Okay, so we know that the rate is going to be R. Okay, R is the second number that we are multiplying by. I just wanted to keep in mind that we have 1 plus our rate here. Okay, well, we got 1.06, so that means our rate has to be 0.06. Now, what we're going to see in a lot of these questions are percentages. So we're going to need to change those percentages to decimals every single time. So just for example, let's say we had 57%. To change a percent to a decimal, you are going to start with your decimal. That's always going to be at the end, or not always, but typically is at the end, and we're going to move that 2 places, 1, 2. So we put our decimal there. The decimal version of 57% would be 0.57. Let's do it again. Let's say we have 2% this time. Okay, I know that I'm going to start with my decimal. It's going to move 1, 2 spaces over here. Something weird, though. We don't have any numbers in front there. So we're just going to replace that with a 0. So we have 0.02. You're just taking your decimal from the back, moving it 2 places. So you're right here now. And we're going to do that same step every single time. It's just going to move 1, 2 spaces. Okay? All right. So let's take a look at one of these in action. Let's do our example 2. Okay. Center that. There we go. Example number 2. The cost of tuition at a state college is $8,500 and is increasing by $3,000 each year. What is the cost of tuition after 6 years? Okay, so I see a bunch of numbers in here. I'm going to highlight all of them. Okay, now we just need to figure out what is our initial value, our rate, and our time. So, initial value is going to be how much it costs us. It says that tuition is going to be $8,500. That will be our initial cost or initial value. That's what we're going to start off with. That's our base. That's what we know. Okay. It's increasing by 3% each year. So it's increasing by this amount each year. That's going to be our rate. Our rate is going to be our percentage. Okay, and then we need our time. Well, the only time we could see here is years, and that's 6 years. So that will be our time. Cool. So, got all of our pieces picked out. Now we're just going to put those into our formula. So we got A, parentheses, 1 plus R to the T power. That was our original function there, right here. We're just going to put that right down there. Okay. Now from here, we're just going to plug in our pieces. So A is going to be our initial value. Our initial value was 8,500, so that's what's going to go there. I'm just going to get rid of it and rewrite it. 8500. There we go. Okay, now we need our R. That's our rate. Okay, we said our rate was 3%, but every time we have a rate, we need to change it into a decimal. So I'm going to go from the back, and I'm going to move 1, 2 spaces. So I got point. There's no number here, so I'm going to put in a 0, 3. So our rate is going to be 0.03. And then T will be our time. We said time was 6 years, so we're going to put in a 6. So now all we have to do with this is figure out what this number is. Everything is already filled out for us. So I'm going to let you know that you could do this by hand or plug it into your calculator. Personally, I would probably just plug this into my calculator. It's a little bit easier that way. Or you can do it by hand, which I'm going to show you now. Just know that you can use your calculator to do this. Okay, so doing it by hand, I know I'm going to have to follow the order of operations. First order is parentheses, so I'm going to go with parentheses first. So that is going to be 1 plus 0.03. So I got that. All right, next thing is going to be exponents. So I'm going to do 1.03 to the 6th power. 0.03. There we go. And I got 8,500 times 1.19. Okay, last one is going to be multiplying. So I'm going to multiply our 8,500 times 1.19. So that should give us 10,149.44. That's got a little squished up there. Okay, so this is money. This is tuition, so I'm going to put a $sign in front of that, and that will be my answer. $10,149.44. That's how much it's going to cost us, or how much tuition will cost after 6 years of it growing. So like I said, I just did it by hand. You can just put it in your calculator, and I'll do that for the next one. So let's move on to example number 3. All right, Sally deposits $10,000 into an account that pays 4.7% interest compounded yearly. What is the balance after 5 years? Okay, so I'm going to use my highlighter. I'm going to go in and just highlight all the numbers. Okay. Now we need to find our initial value, our rate, and our time. Okay, she deposits $10,000. Okay, instantly I know that is going to be my initial value. It's usually the biggest number in the problem. Okay, it pays 4.7% interest. That percent is telling me that this is a rate. And then after 5 years, since it's years, that's telling me it's going to be time. All right, so just like we did before, I'm going to write my formula out and just replace all of the pieces. So initial value is going to be our A. Our initial value is 10,000. Cool. Rate. Our rate is 4.7%, but I need that to be a decimal. So I see my decimals right here. I'm going to move that 1, 2 spaces. So I got point. There's nothing here. So I'm going to put in a 0.047. That will be my rate. 0.047. Time t, that's going to be 5. Cool. Now we just take this whole thing and we're going to put it in our calculator. Now, unfortunately, my calculator isn't going to look the same as yours, but I will tell you that the command is just going to be all this stuff. So if you're plugging it into your calculator, you should have 10,000 parentheses 1 plus 0.047. The way we got an exponent on our calculator was using that caret key. Remember, it's like a little up arrow and then the 5. So that's what it should look like. And then you're going to press the equal sign. After you do all that, we should get a number. So let me put mine in really quick. Plus 0.047, caret 5. And I got 12,581.528. I'm just going to round this to 0.53. Okay, and we're still talking about money, so this is going to have a dollar sign. So we got $12,581.53. That is what's going to be in her account after 5 years. So just make sure to check with your growth functions. Make sure it's going to be a bigger number. So here we started with the 8,500 and we ended up with 10,000, so it got bigger. Here we started out with 10,000 and then we ended up with 12,000, so it's getting bigger. Always, always your growth functions are going to grow and get bigger. Okay, so let's talk about our decay. Decay is going to be the exact same situation. You still have an A, an R, and a T, only now, instead of adding your 1 and your rate, you are going to subtract them. That is the only difference here, is that you're subtracting instead of adding. So you should end up with a smaller number instead of a bigger number. So let's take this. I am going to skip example 4 for right now because we already kind of talked about that. And I'm going to go straight to example 5. Okay, so the student population at the local high school is 1,375 and is decreasing by 2% each year. What will the student population be after 7 years? Okay, getting my highlighter. I'm going to highlight all of the numbers. All right, now I got to figure out what's which. So, student population is 1,375. That is going to be my initial value, or my A. It is decreasing by 2% each year, so it's going down by this rate, R. And our time is going to be 7 years, so that will be our T. Cool. All right, I'm going to write my formula. I got A, parentheses 1. This is decaying. It says it's decreasing, so I got to make sure to put a minus sign. r, and then that's going to be to the t power again. Once again, all I'm going to have to do is replace each piece. So instead of a, I want my initial value, which we said was 1,375. Cool. I need my rate. We said that was 2%, but I got to change that into a decimal. So I'm going to go 1, 2. I got 0.02 instead of r. And then time t, our time was 7, so I'm going to plug in a 7. Now, once again, what I'm expecting you to do is plug this into your calculator. So I'm going to do that. I got 1375, parentheses, 1 minus 0.02, parentheses. Remember, to get that exponent, you're going to need your caret sign. So I got caret 7. All right, press enter, and I got 1,193.67. Okay, something to watch out for here. Context. This is student population. We're talking about people. We cannot have 0.67 of a person. So if you have people or something that is like a solid number, we're going to need to round it up. So I got 1,194 people because we can't have 0.67 people. And that is going to be your answer. After the school population decreases by 2% each year, after 7 years, we'll have 1,194 students. Okay, last one we got is example 6. I'm going to get out my highlighter. An endangered species only has 400 animals left in the wild. If the species is decreasing by 6.5% each year, how many animals are left after 4 years? All right, initial value, they only have 400 animals. So that's going to be my A. They are decreasing by 6.5% each year. That is going to be my R for my rate. And that's after 4 years, so my time is going to be 4t. All right, take my formula. I got A, parentheses, 1 minus, because it's decreasing, R to the t power. Awesome. So A is 400 according to my notes here. My R is 6.5%, but we want to change that into a decimal, so we're going to move it 1, 2. So we have 0.065 instead of R. And then time t, t is 4 years. Cool. Plug all of that into your calculator. 400, parentheses, 1 minus 0.065, parentheses, caret 4. All right, so we got 305.7. But remember, we're talking about animals here. We can't have 0.7 of a creature, so we're going to round it up. So we're going to have 306 left over. After 4 years, they're going to only have 306 of this particular animal. Okay, so like I was saying before, make sure that your decay functions are decaying. They should go from big to small. We started with 400, then it went to 306. We started with 1,300. We went all the way down to 1,100. So be careful. All right. But that is about it for our word problems here. So these are going to be on our test. So please make sure that you understand where the pieces go and why they are going there. Okay. If you have any questions, just let me know. I'm posting practice for this on Teams as well. But that is all I have for you. I hope you have a good day, and I'll see you later. Bye.